We were dealing with image transformations. In the previous session, we saw how we can translate an image, and in this session, we will see how we can rotate an image. Rotation is just turning or rotating the image by an angle of theta. We are using theta to represent how many degrees we are going to rotate the image. For example, since if this is a point, this will be the angle of rotation of the image. Now let's see how we can do the rotation with the help of our OpenCV library. It's very easy to do that. Just like translation, we will be using the OpenCV library called barmejpro to rotate the image also. So in translation, we define a translation matrix. Just like that, in rotation also we need to define a rotation matrix. And one more thing we need to define is we need to specify around which point we want to rotate the image. And normally it will be the central point of the image. In normal use cases, the central point of the image is actually the point which we want to rotate the image. So in here also we take the center point of the image as a rotation point, and we are dynamically getting the center point. That is, we are getting the width and height of the image. Then we are finding out the center point by dividing the width, also the height of the image. So after that we will get the center point of the image, and referring to that point we are going to rotate the image based on the degree of rotation or theta that we specify. So here we have the center point. Now we are defining the rotation matrix. Last time we used numpy function to generate a translation matrix, but here we have a function inside the OpenCV itself called getRotationMatrix2D. Using this function we can get the rotation matrix, and the arguments that this function requires is the center point that we have already found out, then the degree of rotation, that is the theta, the angle of rotation, and also this final argument is the scale of image. So after rotation, the image should be the same size. If it's the same size, then you can specify it as 1.0, and if you want it as a double size or a half size, you can specify it like 2.0 or 0.5 respectively. And we have the rotation matrix defined right now. We have the center point defined right now. Now let's perform the actual rotation. So we are using the barmejpro function, and the barmejpro function of OpenCV takes three arguments here. The first one is image, then the second one is the rotation matrix, and the third one is a center point. So the rotated image will be given here, and we will show the rotated image here in a window. And just like in previous example, to make things a bit easier, we will be creating a common file in which we define the rotation function, and this is our user defined function which takes image, then the angle of rotation, then center of image, then the scale of image. And we are initializing the center as none and the scale as 1.0. So here we have exactly the same code that we seen before. We are calculating the center of the image by fetching the width and height and finding out the half of width and half of height. Then we have our rotation matrix, cv2.getRotationMatrix2D, the center of the image, the angle, and the scale of the image. So here we have an if condition, that is, if the user is not defining the center of the image, then only we have to find the center of the image. Else we don't have to find the center of the image because user is already providing the center location. And in the barmejpro function, we are passing the image, then the rotation matrix, then the width and height of the image, and the rotated image is returned by this function. And this is our main file, exactly like before, importing all the libraries, importing our common file, then getting the arguments, loading the image, showing the original image. Now we will call the rotate function we defined inside the image utils file, imutils.rotate. The first argument is the image, then the second argument is the degree, the angle, and the other two things we didn't specify. So it will calculate the center point automatically. so that we don't have to specify it. The center point will be calculated based on the image that we pass into the function, and this thing will work. That is, if the center is none, that is user is not passing any center, then the center will be calculated based on the image that we pass into this function. And it will return the rotated image. We will show the rotated image and we will implement a weight key of 0. Okay, so let's go ahead and implement this code inside our virtual machine. First of all, we will define the code for our common function inside the imutils.py. We are using the same imutils file to have the rotation functionality also. So we are going to define the rotate function here. Define rotate. The arguments are the image, angle, then center we initialize it as none, and scale we initialize it as 1.0 colon. Now we are going to define the content inside the function. The height and the width will be retrieved back from image dot shape of. So the height and width of the image will be returned back, and we are going to check if the user is passing the center point as none, then we have to calculate the center point. So we are checking if center is none. In that case, we have to calculate the center equal to w by 2, that is width by 2 and height divided by 2. This is an integer division, so that we will not be getting any points, any decimal points while dividing the values. And we have found the center. Now we will define the matrix, the rotation matrix, m equal to cv2. Unlike before, we were using the numpy float 32. Here we have a direct function available in OpenCV, so we are getting cv2.get rotation matrix 2d center, comma, angle, comma, scale. So this is our rotation matrix. Now we are going to pass this into the warp affine function and return the rotated image. So rotated equal to cv2.warp affine. First argument is image, the second argument is the matrix. Then the third argument is the width and height. Exactly the same that we have here. Instead of this, we are using this line. That's all. No other major difference. We are returning the rotated image. And that's all in the common function. We will go ahead with our main function. We can reuse few of the code from the previous example. Till here we can reuse, copy, close, file, new file, paste, save, Ctrl S, rotate.py. Okay, so we are importing the libraries. We are importing our common file. We are fetching the argument, the image path, which is our argument. Then we are loading the image. Then we are going to rotate the image. Rotated equal to, we will call the function from our imutils dot rotate. The arguments are the image and the angle of rotation, which I am defining it like 180, and we are going to show this image 180 rotated, comma, the rotated image, and we are defining a weight key of 0. Okay, let's now try to run this file. We were running it previously, the translate.py. Just change the name to rotate.py and it will run. Yes, we have our cat inverted. We have our cat image rotated 180 degrees. So that's all about rotation. We have successfully implemented the rotation image transformation called rotation, and we will see image resizing in the next session, which is another image transformation. So see you soon in the next session. Have a great time. Bye bye.